Hello students, how are you all? I hope you all are keeping well. So, my name is Priyanka Singh and I am your science teacher. Today I am here to start with the chapter 13 of class 8 science, that is sounds. So, let's start this topic. We hear various types of sounds around us, such as horn of vehicles, loudspeakers, shouting, etc. At times, we may hear buzzing of bee, rustling of leaves, chirping of birds, etc. Types of sounds. Sound is a form of energy which excites in our ears the sensation of hearing. Some sounds like that of a whistle are shrill, while others such as the beating of drums are dull. Some of them like the sound of thunder are loud. Others like the rustling of leaves are soft. Some sounds such as that produced by a guitar are pleasant, while others such as the sound produced by a drilling machine is unpleasant. Each sound has its own characteristics. It is because of these that we can recognize different sounds. Ringing the bell, we come to know that a period is over in our school. Hearing the sound of the doorbell and knock at the door, we come to know easily that someone is at door. Sound plays an important role in our lives. It helps us to communicate with one another. We hear a variety of sounds in our surroundings like bus, helicopter, aeroplane, band, etc. In the music room of our school, we hear the sounds produced by musical instruments like flute, tabla, harmonium, etc. Sound is produced by a vibrating body. As we note that the to and fro motion of a vibrating particle about its mean position called an oscillation. But sound is produced by the vibration in a body. Drive a nail into a wall or any flat wooden surface. Tie one end of a rubber band to the nail and pull the other end. Plug the rubber band from the middle. Does it produce a sound? What kind of motion do you observe in the rubber band? We will see the rubber band starts vibrating as shown in the figure simultaneously. You will hear a sound also. Thus, it clearly proves the sound is produced due to vibrations. When it stops vibrating, it does not produce any sound. The wires of a guitar also vibrate when we plug them. The wires appear hazy while vibrating. Touch a bell gently while it is ringing. Do you feel the vibration? When we strike pan with a spoon, it starts vibrations. And when we touch it gently, we feel the vibration. When we strike the pan again with the spoon and hold it tightly with our hands immediately after striking, we hear the sound. When we touch the pan after it stops producing sound, we do not feel vibration because when pan stops vibrating, it does not produce any sound. Thus, we see that a vibration object produces sound. In some cases, the vibrations are easily visible to us. But in most cases, their amplitude is so small that we cannot see them. However, we can feel them. Musical sound. Continuous vibrations produce musical sound, whereas discontinuous vibrations produce noise. However, this is not all. Listen to the sound produced by a turning fork and the sound of the same fundamental produced by a sitar. The tuning fork sounds flat, whereas the sitar sounds rich. This is because the sound produced by a tuning fork has only one frequency. It has no harmonics. The sound of a sitar has a number of harmonics. Thus, harmonics gives richness, that is, musical quality to the sound. Musical instruments. Musical instruments use vibrations of various kinds to produce music. Depending on the kind of vibrations produced, there are of three types: stringed instrument, wind instruments, percussion instruments. Stringed instruments. In string instruments, music is produced by vibrating a string. When the strings are plucked, struck, or played with a bow, as in a violin, they vibrate to produce a musical sound of some particular frequency. The pitch of the sound can be changed by altering the thickness, tightness, or length of the wires. For example, in a sitar, the shorter the length of the wire, the higher the pitch it produces. Violin, veena, sarod, sitar, guitar, etc. are the examples of stringed instruments. Wind or reed instruments. Wind instruments use vibrations in air column to produce sound. Holes in flute, for example, are open or closed in order to change the length of the vibrating air column. By changing the length of the vibrating air column, we can change the pitch of the sound. Flute, shehnai, clarinet, bugle, and mouth organ are the examples of wind instruments. So it's time for an extra mile. When we pluck a string of guitar, the body of the guitar also vibrates along with the string. The sound we hear is therefore not just of the string but the whole body of guitar. Short column produces sound of higher frequency. This concept is used in Jal Tarang. The bowl which has more water has shorter length of air column, such as the bowl produces sound of high frequency. So next one is percussion instruments. Percussion instruments have a stretched skin whose vibration produces sound. Loudness is increased by striking the skin harder. The pitch is increased by stretching it more. Dholak, drums, bongos, tabla, mridangam are the examples of percussion instruments. Beside above, some more instruments are commonly used in many parts of our country like majira cymbals, ghattam nut, mud pots and kartal. And these are the pictures of dholak, manjira and ghattam nut. Sound produced by humans. The larynx is the body's voice box. Put your finger on the throat and find a hard bump that seems to move when you swallow. This part of the body is known as the voice box. This is the diagram of a voice box in humans. So go through it. It is at the upper end of the windpipe. The voice box has two vocal cords. They are stretched across the voice box in such a way that it leaves a narrow slit between them for the passage of air. When we speak, lungs force air through the passages, due to which the cords start vibrating and produce sound. Muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type or quality of voice is different from that when they are loose and thick. With the help of the following activity, let us see how the vocal cords function. Women have shorter vocal cords than men. Children have very short vocal cords. That is why the frequency of sound produced by women and children is of higher frequency than sound produced by men. Characteristics of sounds. First one is loudness. If you strike a drum softly, it produces a soft sound. If you strike it hard, it produces a louder sound. In the other words, in the first case, vibration with small amplitudes are produced, and in the second case, vibration with large amplitudes are produced. This shows that loudness of a sound depends on the amplitude of vibration. It is measured in decibels. Loudness of sound is expressed in the units of decibels. Some sounds and their decibel is as follow. First, normal breathing, 10 decibel. 2. Soft whispering, 30 to 40 decibel. 3. Talking, 30 to 40 decibel. 4th, teacher, 40 to 50 decibel. 5th, radio or TV, 40 to 50 decibel. 6th, moving car, 60 to 70 decibel. 7th, motorcycle, 90 to 100 decibel. 8th, factory, 80 decibel. 9. Thunder, 120 to 150 decibel. 10th. Jet planes, above 150 decibels. Now, pitch. Drive a nail into a wall. Stick one end of rubber band to the wall. Now stretch the rubber band only slightly and strike it. It will produce a dull sound. Pull it hard and strike it again. A more shrill sound will be produced. Observe the vibrations carefully in the two cases. You may be able to make out that the rubber band vibrates faster when producing a shrill sound than when producing dull sound. The shrillness or flatness of a sound is known as pitch. The pitch of a sound depends on the frequency of vibration. The higher the frequency of a sound, the higher will be its pitch. A woman's voice generally has higher pitch than a man's voice. This is because the frequency of a woman's voice is higher. The thinner wires of a guitar or sitar give out sound of higher pitch than the thicker wires. The thin vibrate with greater frequency than the thick wires. Also, a guitar wire vibrates with higher frequency if tightened further. This is true for the skin of a tabla also. If you tighten the skin, it produces sound of higher pitch. Sound needs a medium for propagation. Sound is a form of energy and is produced by a vibrating body. The vibrating body transfers its energy to the neighboring molecules in the medium, which in turn pass on their energy to other molecules. The mode of travel of the sound from the place of origin to the distant place is known as propagation of sound. Sound needs a material medium like solid, liquid, and air to travel and be heard. Sound travels in waves. So, it's time for an extra mile. Sound wave is called mechanical wave because it needs a material medium to travel. It cannot travel in vacuum. Sound needs air for propagation. Take a metal glass. Make sure it is dry. Place a mobile in it. Ask your friend to give a ring on this mobile from another mobile. Listen to the ring carefully. Now surround the rim of the glass with your hands. Put your mouth on the opening between your hands. Now indicate your friend to give a ring again. Listen to the ring while sucking air from the glass. Does the sound become fainter as you suck air? Remove the glass from your mouth. Does the sound become loud again? Can you think of an explanation? So, an extra mile. Heinrich R. Hertz, 1857 to 1894, a German psychist, discovered the electromagnetic waves and used them in the development of radio, television, and radar. He made use of an electric spark to produce waves of very high frequency. SI unit of frequency, Hertz H2, is named after him. Indeed, if you had been able to suck all the air in the glass, the sound would stop completely. Actually, sound needs a medium to travel. When air has been removed completely from a vessel, it is said that there is a vacuum in the vessel. The sound cannot travel through a vacuum sound, therefore requires a medium to travel. This is the picture which is showing sound needs a medium to travel. Sound travels in solid for propagation. Put your ear to one end for a long wooden or metallic table. Ask your friend to tap softly or scratch on the other end of the table. Can you hear the sound? We will be able to hear our friend tapping or scratching desk very clearly. We find that sound can travel through wood or metal. In fact, sound can travel through any solid. We can perform interesting activities to show that sound can also travel through strings. Sound travels in liquid for propagation. Take a bathtub. Fill it with clean water. Take a small bell in one hand. Shake this bell inside the water to produce sound. Make sure that the bell does not touch the body of the tub. Now place your ear gently on the water surface. Can you hear the sound of the bell? Does it indicate the sound can travel through liquids? We will be able to hear the sound clearly. This shows that sound can travel through liquids also. Thus, we find that sound requires a medium to travel, which can be solid, liquid, or gas. How we hear the sound? We hear the sound through our ears. Our ears are sensory organs that help us to hear sound. Only one of its parts can be seen and felt by us, that is the outer ear. The rest of the delicate ear is buried deep inside the skull. So students, this is the diagram of a human ear. So go through it. The shape of the outer part of the ear is like a funnel. The outer ear catches sound and sends it to the middle ear. The middle ear has the eardrum. When the sound falls on the eardrum, it starts vibrating. These vibrations pass into the inner ear. From here, the nerves send the message to the brain. This is how we hear audible and inaudible sounds. Our ears can only hear sounds with frequency ranging between about 20 Hz to 20,000 Hz. This is called the audible frequency range of sound. Such vibrations are called sonic vibrations or sound vibrations. Low frequency sound less than 20 Hz, which we cannot hear, are called infrasonic objects that vibrate at frequencies of about 20,000 Hz, produce sounds, which also cannot be heard by us. Such sounds are called ultrasonic. Human beings cannot perceive either infrasonic or ultrasonic sounds. Hence, these are called inaudible sound. That is, sound we cannot hear. Thus, for human ear, the range of audible frequencies is roughly from 20 to 20,000 Hz. So, it's time for an extra mile. Some animals can hear sounds of frequencies higher than 20,000 Hz. Dogs have this ability. The people use high frequency whistles which dogs can hear but humans cannot. Amplitude, time period and frequency of a vibration. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. Show the pendulum of rest in its mean position. When the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. So these are the diagrams. This is a simple pendulum and other pendulum is showing different positions of the bob of an oscillating simple pendulum. The to and fro motion of an object is known as vibration. This motion is also called oscillatory motion. The number of oscillations per second is called the frequency of oscillation. Frequency is expressed in Hertz. Its symbol is Hz. A frequency of 1 Hertz is 1 oscillation per second. Amplitude. If you give the ball a small push, the oscillation of the ball above the control position are small. If you give the ball a stronger push, the oscillations are longer. The distance by which the ball moves away from its central position is called the amplitude of the oscillation. Thus, the maximum displacement of the bob from the mean position during the oscillation is called amplitude of the oscillation. In the case of simple pendulum as shown in the figure, the amplitude is AB or AO, time period. The pendulum is said to have completed one oscillation when its bob starting from its mean position O moves to A, to B and back to O. The pendulum also completes one oscillation when its bob moves from one extreme position A to the other extreme position B and come back to A. The time taken by the pendulum to complete one oscillation is called its time period. Thus, the time taken by the vibrating body to complete one oscillation is called the time period. It is different to measure the time for a single oscillation. Therefore, if we measure the time taken for 10 oscillations and divide the total time by 10, it will give us the time taken for one oscillation. Also, if we measure the time several times for different amplitudes, we will find that the time for one oscillation remains the same no matter what the amplitude. Frequency. If we count the number of oscillations of a pendulum in say 60 seconds and divide the number by 60, it will give us the number of oscillation per second. This is called the frequency of oscillation. For a pendulum of given length, the frequency remains constant. Frequency is denoted by the letter F. The unit of frequency in SI unit is Hertz, Hz or S. When a vibrating body produces 20 vibration oscillation in 1 second, its frequency is said to be 20 Hz. If the frequency of a counting fork is written as 200 Hz, it means that it produces 200 vibrations in 1 second. Relation between time period and frequency. Time period is denoted by the letter T. If F is the frequency and the T is the time period, then F vibrations are complete in 1 second. One vibration is completed in is equals to 1 divided by F, that is frequency. We know that the time taken to complete one vibration is its time period T. T is equals to 1 divided by F, or time period is equals to 1 by frequency. Noise and music. We hear different types of sound from a variety of sources around us. Some of these sounds are pleasant to ears while some are not. Sound that is pleasant to our ear is called music. A sound that does not sound pleasant to our ears is called noise. Suppose construction work of a building is going on in our neighborhood. Are the sound coming from the construction site pleasing? Do you enjoy the sound produced by horns of scooter, bus, truck and train? Perhaps no such unpleasant sounds are called noise. If all the students in a classroom speak together, the sound produced would also be called noise also. On the other hand, we enjoy sound from musical instruments. Suppose a marriage function is going on in our neighborhood. We enjoy the sound produced by musical instruments. Thus, musical sound is one which is pleasing to ear. Sound produced by a harmonium is a musical sound. The string of a sitar also gives out a musical sound. But if a musical sound becomes too loud, would it remain melodious? No, never it becomes noise. Noise pollution. We know about air pollution. Presence of unwanted gases and particles in air is called air pollution. Similarly, presence of excessive or unwanted sounds in the environment is called noise pollution. Too much noise in our surrounding is harmful to us. Automobiles, buses, heavy machines in factories, loud uproar from religious, cultural and political gatherings, rock bands, loudspeakers, etc. are the main causes of noise pollution. Television and transistors or radio at high volumes, some kitchen appliances, desert coolers all contribute to noise pollution. Harmful effects of noise pollution. Presence of excessive noise in the surrounding may cause many health-related problems. It can cause irritability, loss of concentration, high blood pressure, headache, stress, sleep disturbances. A person who is exposed to a loud sound continuously may get temporary or even permanent impairment of hearing. Measures to limit noise pollution. To control noise, we must control the sources of noise. We must follow the following. Silencing devices must be installed in aircraft, engines, transport vehicles, industrial machines and home appliances. All noisy operations must be conducted away from residential areas. Noise-producing industries should be set up away from such areas. Use of automobile horns should be minimized. Television and music systems should be run at low volumes. Reducing noise emissions by developing low noise products, for example, low noise automobiles engines. Control over recreational noise such as use of loudspeakers. Trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of noise pollution. Increasing public awareness of noise by providing factual information of the effects of noise such as blowing horns, playing loud music and TV, etc., with a view to influencing behavior to avoid noise generation. Above given measure can, however, only be succeeded if supported by the public. So students, it's time for Reader's Digest. So, sound is produced by the vibrations in a body. In human beings, sound is produced by a voice box or the larynx of our throats. Loudness of a sound depends on the amplitude of vibration. The frequency is expressed in Hertz, that is Hz. More trees planted on the roadsides to act as noise buffers. So students, it's time to take your leave. We'll meet in the next class. Bye.